Hello, everyone, and welcome back to the Aquarium of the Pacific's online academy. My name is Dana. I'm a member of our education team here at the Aquarium in Long Beach, and I'm so happy you're joining us today because we are talking about one of my all-time favorite subjects. We are going to be talking about the science of scuba diving today. Scuba diving is amazing, it's fun, it's such a great activity, but there's also a lot of science involved. And so we're going to kind of dive into that, if you will, and explore what some of those scientific laws might be and what some of the things that a diver has to think about before dropping down to depth. During this program, we would love to have you joining us and participating. Up here on the bottom of the screen, you'll see a number pop up, and we will be taking questions right there, 562-286-1838. And we will be taking questions throughout the program and trying to talk about specifically to what you are interested in. All right. If I'm saying something and you want to know a little bit more about it, that's a great opportunity to text in. If you're thinking about diving and you want to know some fun facts, another great reason to text us. I'm joined by two friends in the studio. I have Emily back here who's going to be controlling what you see going on behind me. And then I have James off to the side who's going to be taking your questions and passing them in to me. Again, we'd love to hear from you. And if you're watching not live, if you're watching after we've already streamed this and you've found us on YouTube or on our aquarium website, then we'd love to still be able to answer your questions. We actually do have a email address that's available for you to use. It's going to be live, L-I-V-E, at lbaop.org. Once again, that is live at lbaop.org. Again, if you're watching after the fact, please feel free to participate as well and reach out at that resource. Otherwise, we're going to get started here, and we're going to start the same way we like to start most of our programs. We are going to be starting with observations. All right. So today we're all scientists, and scientists like to look at things, right? We like to ask questions. We like to share what we notice with those around us. So let's take a look at what's on the screen right now. What do you notice on the screen? Well, I am noticing quite a bit of fish move. Ooh, there's a big fish moving around, right? These are half moons. They're swimming through our blue cavern exhibit. This is our Honda Blue Cavern exhibit. It is one of the taller windows that you will see if you've ever been or hoping to come to the Aquarium of the Pacific. And it's actually modeled after a local dive site. This dive site, Blue Cavern, is found out at Catalina Island. And I'm going to talk about Catalina a couple times today because it is an amazing dive site that a lot of people write off, because when people think, oh, I want to go scuba diving, usually we talk about the tropics. Warm water, lots of colors. But we are so fortunate to have a beautiful habitat just like this on the screen. So some things that really jumped out to me just now are the rocks, the rocky and kind of sandy bottom, and of course, this algae growing behind me, and that is called giant kelp. So this habitat represented behind me is a kelp forest. And the animals swimming, beautiful. Look at this. Look at the way the light shines through. All right. This is one of the best places to dive, in my opinion. But there's a lot that I have to think about before jumping into the water and exploring the habitat. And so think about the animals that live in a kelp forest. Well, we've got a lot of invertebrates. Those are animals that don't have a backbone. But you and I, we have backbones. And so we're going to have to factor that in, right? We're not going to be sitting on the seafloor drifting through the ocean like an invertebrate. Instead, we're going to be swimming. So let's take a look at the fish. Let's go back to Blue Cavern here and see what the fish are doing. All right. Let's see here. So we've got the kelp. Look at that movement. I love it. I love it. I love it. Whoever got this footage, this is the best footage of a kelp forest. So we'll pull Blue Cavern or Amber Forest up here. Here we go. So check out these fish. Now, as they're swimming around, are they popping up to the surface? No, definitely not, right? Are they sinking? Are they on the bottom of the seafloor? Not quite. So fish, they like to hang out kind of in the mid-water column, depending on the species. Some are at the surface, some are at the bottom, but fish in general are somewhere in the middle, right? But how do they stay there? Okay, and that's what's going to lead us into our talk about buoyancy later on. What else do they have that allows them to be underwater? Well, they've got these fins that really help them out, right? As that one swims away. Fins allow fish to move through the water. Oh, like this Garibaldi right here. They have a little heart-shaped fin. I love this one, right? This is actually the California state marine fish, and they are a fish that's found in our local kelp forests. And so these fins help them move. You and I have kind of awkward arms and legs. Great for walking around. Not always so great when you're trying to be a fish underwater. What else do they have? Well, these fish here, this is a really good image of them hanging out in the water column, right? Some of them aren't even swimming. They're just floating, right? So again, we'll talk about that neutral buoyancy here in a little bit. But how are these fish breathing, right? What are they doing? Well, fish have gills. Gills, they have a gill, this is actually called an operculum right here. This is kind of a bony plate that protects their gills. You and I do not have that, right? Raise your hand if you wish we had gills, because I know I certainly do. That would make being a diver much easier. However, we don't have gills, so we have to do something else. So they have gills, they have fins, they also have scales covering their body, right? It's kind of like a plate of armor almost. It protects them from the environment. And so all of these things that make a fish, the gills, the fins, the scales, all that stuff, scuba divers had to find a way to do that ourselves. So I'm going to bring in a friend of mine. All right, this is Sherwood. Oops, roll on over here. Okay, now, Sherwood and I have done a lot of dives together. All right, we've had a blast underwater. But we're also going to kind of talk it out and take a look at the gear that Sherwood has and see if we can figure out how we became fish, okay? Now, scuba diving. Scuba. If you've ever seen it written out, oftentimes scuba is all capitalized. And that's because it's not just a word that somebody made up. It actually stands for something. SCUBA. Self-contained underwater breathing apparatus. So the first thing that divers needed to figure out is how to breathe, right? So if you take a look at the back here, Sherwood has a really big tank. Now, I want you to think about this for a second. What's in Sherwood's tank? Well, what are you and I breathing right now? Take a deep breath with me. 1, 2, 3. That felt great. Now, I didn't breathe in pure oxygen. I didn't breathe in nitrogen. I didn't breathe in helium. Instead, I was actually breathing in a mixture of all sorts of gases. Now, the air that we're breathing, while we all assume it's mostly oxygen, it actually is mostly nitrogen. It's about 78% nitrogen, 21% oxygen, and 1% of other gases. And that's exactly what you would find inside of this tank right here. We just took ambient air, that's the air around us, and smushed it into a tiny little container on Sherwood's back. And so there's about 80 cubic feet of air in here, which is kind of the size of like a bathroom, okay? And so lots of air for Sherwood to breathe. And then they have to find a way to get it to their mouth. So divers will have this handy dandy thing right here. This is called a regulator, okay? You can see it has a little mouthpiece. If you've ever been snorkeling, it's the same thing that's going to fit in your mouth there. You're going to put it in your mouth and take a breath. Now, this is designed to lower the pressure, right? This tank is under a lot of pressure. It's a lot of air squeezed into that tiny spot. And then there's different stages of our regulator that take that from high pressure to medium pressure and then to what we call ambient pressure. If you recall, that means kind of the environment around you, right? And so Sherwood can take a big breath off of the regulator, and then they're slowly going to use the air in that tank. Now, what that means is divers have a limited air source, okay? You and I can walk around, go about our daily duties, and breathe without really thinking about running out of air, right? Divers have to constantly be prepared to recognize how much air they have. And to do that, they have this. This is called a pressure gauge. And it tells Sherwood and other divers just how much air is left. In fact, one thing that divers will do is you always dive with a buddy. And you should be in check with your buddy. You want to know how much air your buddy has as much as how much air you have. So if James and I were on a scuba dive together, I might look at James and say, how much air do you have, right? Can I ask him that? Can we talk down there? Not really. But divers have come up with a great way to communicate underwater using a series of hand signals. And asking about air usually looks like this. How much air do you have? And then Sherwood or James or myself can look at our gauge. we can know how much air we have, and we can communicate just how much we have left. Now, I mentioned the science of diving, right? So it's easy to say, oh, well, I have blah, 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 blah air left. But what's important is knowing how much air you might use, how long that really means. What if I'm on a scientific dive? What if I have to go down and perform a task, do a scientific observation or a scientific experiment down there? I have to be able to calculate just how much air I have, how much time I might have, and decide, is the task that I'm trying to perform going to be possible given the air that I'm breathing? Right? So there's a lot to think about. Now, for just the average recreational diver, I don't usually think about that stuff. I know roughly that I'll last this long, and I know how much air I have, and I can calculate it out. But I'm mostly going down there with a plan set beforehand, and we'll talk about dive planning as well. Now, some other gear that Sherwood has that I mentioned turns us into a fish. Well, Sherwood has this big wetsuit, right? So I mentioned the scales on a fish's body. Our wetsuit acts like our scales. It's what we call exposure protection. And it's going to protect us from the surrounding environment, whether that's, oops, we brushed up against a rock, or oops, there's a fish that swam by and got a little too close, though that doesn't happen very often. But more importantly, it's going to protect us from the temperature, okay? So if you've ever been in the water off of our California coast, it can get really cold, right? Especially if you got certified up in Monterey, which is where I got certified. It is really, really cold. Now, down here in Southern California, our temperatures fluctuate a little bit more, all right? And so sometimes I can be diving in 75-degree water, and sometimes I can be diving in 60-degree water. That is drastically different. However, my wetsuit is going to keep me warm in whatever temperature that I'm diving in. So exposure protection, we've got our air and our regulator. We can pay attention to it. Well, what else? What do the fish have that we don't? Right. Let's take a look at them again. You can see them swimming. You can see them floating. You can see the little tail movement right here. So fish have fins, right? Now divers, we also have fins, like this one right here. Okay, and so fins allow us to move a little bit stronger through the water. If you saw on the screen just now that those kelp were moving back and forth, right? There we go, just like that. And so that's called surge, but you're also down underwater fighting currents. And so I'm a really strong swimmer. I actually swam from the age of 4 all the way up to 21. I have a lot of experience in a pool. Right? Once you get into the ocean, things are a little bit different. And so fins allow me to be a stronger swimmer underwater. And that's really important because you don't want to waste so much energy that you find yourself in a compromising situation. So let's see. Sherwood's got air, a way to breathe the air, a way to tell how much air they have. They have their fins. They have their exposure protection. They've got a mask to be able to see. I think we're ready to go diving. All right. So we're going to send Sherwood off. They're going to go for a dive and with their buddy, of course, and they'll come back and report to us what that's like. And while they go do that, we're going to answer a couple questions here. So Gage wants to know, Gage, welcome back. Excited to have you joining us. Have you seen or have you been injured by a shark? I love this question because it really opens it up to a broader subject. Now, the first part was, have I seen a shark? And yes, I have. It's so exciting. The second part of that question is, have I ever been injured by a shark? And no, I have not. And what I mean when I say it opens it up to a broader question is injuries from animals in general, right? I want to remind you, friends, that when I'm diving, I'm the weird one in the water, okay? Animals are just going about doing their daily thing. And so oftentimes, as a scuba diver, I'm releasing bubbles, I'm making noise, I'm awkward. A lot of animals are swimming away from us, okay? So if I do accidentally get an injury, which I will share one. It was from a crab. It was actually my fault, okay? And most of the time it is when you're in a situation like that. I accidentally put my hand down to steady myself against the current, and I put it a little too close to the crab. And the crab was not out to get me, but it got scared, right? A big, awkward, clumsy diver showed up, got a little too close, and so it protected itself. So I want you to remember, when it comes down to injuries from animals, it's often them protecting themselves. And so you want to make sure that you're being respectful of the habitat around you. Now, Caleb wants to know, how long does a scuba tank last? Caleb, that's a great question. I mentioned that gauge. I'll kind of bring it back in here. Now, when I say gauge, I mean a pressure gauge, not gauge like who just asked the last question, right? And so a gauge is going to tell me how much air I have left. It depends on the size of the tank. Tanks can come in a variety of different, here we go. So this picture coming up is actually going to be me and my friend Katie on a dive. So this is me. That's okay. Perfect. This is me right here. This is Katie. You can see Katie actually has a gauge and her computer, which I'll talk about later on, in her hand, okay? And so one thing that we're going to be paying attention to is how much air we have. Like Caleb wanted to know, how long will it last? An average diver on an 80 cubic foot tank, depending on the temperature and how much they're fighting the current and how heavily they're breathing, what kind of shape you're in, that's all going to depend on how, or that's going to factor into how fast and how long a tank can last. And so I would say on average 45 minutes to an hour for that kind of tank. However, there are some adjustments you can make, right? One of those adjustments is actually changing the composition of the gas you're breathing. If you recall, I mentioned the 78 nitrogen, 21 oxygen, and 1% other. There's ways to adjust that kind of change how your diving is and what you're breathing. And so that can help things last longer. Different size tanks can help things last longer. So there's a lot of different things that you can factor into, but I'm usually underwater about 45 minutes to an hour, maybe a little bit longer. All right. So those were great questions, my friends. Like I said, if you want to join us and ask more questions, we will throw that number up on the screen periodically to remind you. Just remember that it does, it is normal texting rates, and make sure you have adult permission to join us today. So again, that number is 562-286-1838. I'd love to hear more from you. So we're going to check back in with Sherwood. We're going to roll them over here. All right. And now we're going to talk about one last piece of gear that'll roll us into our buoyancy discussion. Okay. And that gear is this big, bulky jacket that Sherwood is wearing. Now, this is called a buoyancy compensation device, or a BCD is what we call it for short. And a BCD is just a vest, right? It can come in different forms, but a very common form is a vest, just like this. But inside of this vest, there's actually what's similar to a balloon, okay? It can blow up with air, or it can release air. And that is important because it turns us in to a fish in the last little way. And that is through providing us with what's called a swim bladder. Okay, so we're going to put some fish on the screen again. I want you to watch how they're staying in the water column. Remember, I mentioned that they're not floating on the surface and they're not sinking to the bottom. And like I said, this is a great representation of that. So especially this fish right here. What is it doing? Is it even struggling to swim? No, not at all. So if you take a look at it, what's happening right here is that fish is maintaining its neutral buoyancy by using its swim bladder. Now, a swim bladder is a gas-filled sac in the body of a fish. And again, you can think of it like a balloon, okay? If you fill a balloon up with air and you hold it underwater, right, it's going to be going up. But if you release all that air, a balloon's going to kind of sink, okay? You can do that with helium as well, and it's gonna, right, a balloon will float with helium in the air and sink without it. And so that gas-filled bladder within the fish allows them to figure out that level. Am I gonna hang out right here, like this fish? Am I gonna hang out right here, like this fish? Okay. Am I gonna be down on the bottom, right? In fact, we do have one fish. Oh, it looks like they might have gone behind the rock, but keep an eye out right down here. We have a really special fish there that likes to show up. And so fish can determine where they're hanging out with that swim bladder. But how do divers do it? Well, let's think about an average human, okay? An average human in their birthday suit is something called positively buoyant, okay? I want you all to close your eyes and picture yourself on the side of a pool, okay? You can be on a diving board if you want to. And on the count of 3, we're all going to jump. 1, 2, 3. What happened? Well, for me, the first thing that happened was I went down into the water, but then I came back up, okay? Now, like I said, the average person is positively buoyant. And what that means is they are more likely to float. Okay, so let's talk about buoyancy here. I'm going to bring two objects out. Now, I have a disc. Okay, this is like a washer. And I have a ping pong ball. Now, they're kind of the same size, not the same shape, right? But similar size. One floats and one sinks. Why is that? Okay. So buoyancy also deals quite a bit with density. Now, a buoyant force, okay, when I jumped into that pool just now, I exerted a force on the water. But the water also exerted a force on me, and that was the buoyant force. Now, buoyancy is the force of an object, is the force of the water pushing back up on that object, okay? If the force is equal to the amount of water displaced by that object, okay? So like I said, we're getting really scientific here. It's equal to the amount of water, the weight of the water displaced by that object. So an elephant is going to displace a lot of water compared to a mouse, right? A mouse is not going to displace much. But these two similar sized objects, okay, they're going to displace similar amount of water. Now, one of them will sink and one of them will float, like I said. So how come they do two different things even though they're roughly the same size? Well, that's where density plays a part. The density of an object determines how much matter is within it. Now, this is hollow, okay? This is really solid in here. And so, if the weight of the object is less than the buoyant force, it's going to float like our ping pong ball. If the weight of the object is more than our buoyant force, it's going to sink. Okay, so let's take two identical objects, two ping pong balls. Well, this one's hollow, but this one's full of sand. Which one's going to sink and which one's going to float? Well, they're displacing the exact same amount of water, and yet this one is more dense and this one is heavier. And so the buoyant force will be equal, but this will sink and this will float, okay? So divers have to factor all of this in, because if an average person jumps into a pool or an ocean, we're going to float. We're going to be positively buoyant right on the surface of the water. But is that where a diver wants to be? Not particularly. Divers like to hang out on the bottom of the seafloor, right? Or nearby. And so divers have to find a way to be negatively buoyant and get underwater, but not so negatively buoyant that we're walking along the seafloor. That kind of defeats the point, okay? So we have to find a way to be positively buoyant like I am right here in this photo. Now, this is me diving in an exhibit. It's a little bit different, right? You can see a cord right here. That's a communication cord. So I mentioned that as dive buddies, we don't typically talk to each other, but when you're in a controlled environment like a zoo or aquarium or another facility you might be diving at, there's ways to communicate. But as you can see, am I standing on the seafloor? Nope. Am I floating on the surface? Nope. So what I did was I found a way to be negatively buoyant enough to get down underwater, but positively buoyant enough to hover. And that is what we call neutral buoyancy, okay? So let's bring Sherwood back in. We're going to talk a little bit more about the gear and how it plays a part in buoyancy. So Sherwood as a body is pretty positive. So how do we get below the surface? Well, that's where weights come in, okay? Divers often will wear a weight belt, or some BCs have a little pocket right here. It's called weight integrated, and it's built into your BC. You can fill it with weight. And that's going to allow us to drop below the surface, okay? So their body is positively buoyant. Wetsuits are made of something called neoprene, and there's a lot of air space, and that creates wetsuits as a positively buoyant factor. And so wetsuits float, bodies float, so the weights really have to help us out. Tanks can kind of be both. Okay, it depends on what kind of tank, what material, what metal it's made of, and also if it's the beginning of the dive or the end of the dive, right? Because air is going to play a little factor. So tanks can be both, depending on what kind. What about the BCD, right? Remember, I called it the buoyancy compensation device. Well, if I'm trying to go deeper, I'm going to be letting air out, right? This is actually how we do that. So this is a hose. This hose let's see if I can turn it. There you go. This hose is from the tank. This is how you add air to a BCD. This hose, that's how you release it, okay? And so if I'm trying to sink, I'm going to be releasing air, right, and going down. But what if I'm trying to stay right here? Well, I put just enough air in to hover. Not so much that I shoot up, but not so much, or not so little that I'm sinking still. So again, a buoyancy compensation device. I want you to now think of that as a diver's swim bladder, just like that fish who is hanging out in a mid-water column area. That's what divers are trying to do as well. So now we understand a little bit about how divers get to where they want to be in the water. We're going to take a look at some of your questions that are coming in, and then we'll talk about one last dive subject, okay? Now, Aiden wants to know, how heavy is the air tank? Great question, Aiden. A lot heavier than the average diver prefers, right? So depending on the metal that I mentioned, scuba tanks are usually made of either aluminum or steel. And so they're pretty heavy, especially when they're a full tank and you're carrying it around. And remember, it is pressurized air. And so think of like an aerosol can, right? When you press a button, the air goes, right? Or any substance that's in that. Well, if something happens to a scuba tank, the same thing's going to happen. So they're very heavy, and you also have to be very careful not to drop it or anything like that. So it's a bit of a workout. Now, we also had a question, I believe it's Tyon, wanted to know, how deep have I dove? Great question. Let's see, my deepest one was 103 feet, okay? And this is a big deal because most dives that I do are only around 30 to 45 feet. Sometimes we hit the 60 to 70 foot range, but it's always really special to go to your first 100-foot dive. And I remember it very vividly because I actually have a picture of myself holding my gauge, and it says 100 on it. And I have a big fat smile on my face, so it was pretty special. The average recreational scuba diver, our limit is 130 feet. There are ways to dive much deeper, but the average scuba diver is going to be usually in that 45 to 70 foot range and 130 foot max. Now, Benjamin wants to know, what happens if your tank has a hole or a leak? Ooh, Benjamin, that's scary, right? Now, the tank itself, if it had a hole, okay, you remember I said that it's pressurized air, okay? Think of that like a balloon, okay? So everybody take your balloon out. All right, we blew up our balloon. Now, what happens if we take a pin, right? That balloon goes, and it pops. And the same thing's going to happen to a tank. It is pressurized air. If there was a hole in it, we call that a catastrophic blowout. It's not going to end well, okay? Now, leaks, that happens. Not necessarily from the tank, but from your regulator, okay? And so you can see this happening sometimes. If you ever watch a diver in an aquarium or in a zoo or in any kind of enclosed space or on a movie or film, you can sometimes see little air bubbles coming out, right? And that could just mean the seal is a little wrong. It could mean something called an O-ring. It's a little rubber ring that kind of seals the connector. It might mean that the O-ring is damaged, and so there might be a little air leaking out. It depends on how bad the leak is, right? For the most part, you're going to want to make sure that all of your gear is in tip-top shape so that you don't have leaks and you don't have anything wrong. All scuba gear has to be serviced, right? You want to take your regulator in. That's like your life source. You want to make sure that all the pieces are working correctly. You want to take your BCD in, make sure everything is working the way it should. And you get your tank checked out. Tanks undergo 2 different inspections. One of them is a visual inspection. Dive technicians will actually take the top of the tank off. They'll look in there. They have a light. They do all this stuff. They look for any rust. That means water got in there. They look for any internal damage, right? So there's a lot of things to inspect. And then they also get a hydrostatic test. And that's one that usually the tank has to get shipped out to someone else who will do it. They'll check it. I don't know a whole lot about how that works, so I'm not going to try to explain it. But it does ensure that you don't have those catastrophic blowouts, like I mentioned. You don't have any damage to your tank. And so you're constantly getting it looked at and making sure. You have to do a hydrostatic test, I believe, every 5 years. And so divers, we want to dive, but we want to do it safely, right? And safety, I'm going to wrap it up here pretty soon. Safety is a #1 part of diving. You always want to make sure you're doing it safely because things can go wrong. And one of those things that I want to explain is called decompression sickness, okay? Now, this deals with a lot of pressure laws and physics and physiology, which I am no expert in. So I'm going to kind of give you the bare bones answer, all right? Decompression sickness is what happens when you're breathing air at depth, okay? So we're going to talk a little bit about pressure laws just for a quick minute. Pressure, as you go deeper underwater, the pressure increases. And so air, as you're breathing it down below, you're breathing denser air, okay? And I've mentioned the